Why time runs faster on Mars? Time rules everything we do. It decides when we wake up, when we work, and how we measure every moment of our lives. But what if I told you that time itself does not flow the same way everywhere? What if the passing of seconds changes depending on where you stand in the solar system? This isn't science fiction. This is Einstein's universe, and new research shows just how differently time unfolds on Mars compared to Earth. Ask anyone on Earth for the time, and you'll get a precise answer. That accuracy is possible because we rely on one of the most advanced timekeeping systems ever created: atomic clocks, GPS satellites, and global digital synchronization. But Einstein shattered the idea of universal time. He proved that gravity bends time, motion stretches it, and the universe does not tick in perfect harmony. So what happens when we step off Earth and onto another planet? What time is it on Mars? And will the clocks we use here still work on the red planet? This question became crucial as NASA prepares for long-term human missions to Mars. And now, physicists at the National Institute of Standards and Technology, NIST, have finally produced the first ever detailed calculation of Martian time. What they discovered is astonishing. A clock on Mars runs 477 microseconds faster every day compared to an identical clock on Earth. This difference may sound tiny, just a few millionths of a second, but in the world of precise space communication, navigation, and timekeeping, that difference is massive. It could affect how rovers explore the surface, how satellites communicate, and how astronauts navigate the planet. But here's where things get even stranger. That time difference isn't fixed. Mars has an eccentric, stretched-out orbit around the Sun, and its position is constantly influenced by the gravitational pull of nearby planets like Earth, Jupiter, and Saturn. Because of this cosmic tug-of-war, the daily time drift on Mars can change by up to 226 microseconds over a Martian year. In simple terms, time speeds up and slows down on Mars every single day. To understand why, we need to revisit relativity. Einstein showed that gravity affects the flow of time. Stronger gravity slows clocks down. Weaker gravity makes clocks tick faster. Since Mars has only 1/3 of Earth's gravity, time naturally moves a bit more quickly on its surface. But the story doesn't end there. The velocity of a planet's orbit influences time as well. Faster orbital speeds slow clocks. Mars moves differently through space, following a more stretched and uneven path around the Sun. That varying distance changes the gravitational forces acting on it, leading to shifting clock speeds. So how did scientists measure all of this? NIST physicists Bijanath Patla and Neil Ashby used decades of data collected from Mars missions. They chose a specific reference point on the surface of Mars, similar to how Earth uses sea level as a standard. Then they calculated gravitational strength, orbital velocity, and all the influences from surrounding bodies, including the Sun, Earth, the Moon, Jupiter, and Saturn. This wasn't just tricky. It was one of the most complex time calculations ever attempted. In fact, according to the researchers, the heavy lifting was far more challenging than expected. Mars' orbit is so eccentric that traditional models simply couldn't predict the time differences without deep relativistic analysis. And why does this matter? Because time is the foundation of technology. 5G networks require accuracy to within 1/10 of a microsecond. GPS systems rely on atomic clocks that cannot drift, even slightly. If future Martian colonies use timekeeping systems that go out of sync with Earth, everything from navigation to communication could break down. Imagine rovers driving on Mars with desynchronized clocks. Imagine satellites missing signals by fractions of microseconds. Imagine trying to land spacecraft with outdated timing information. The consequences could be catastrophic. Right now, communication between Earth and Mars takes 4 to 24 minutes due to distance. But if we ever want real-time interaction, or near real-time, we need synchronized clocks across planets. We need a solar system Wi-Fi, a cosmic internet, a network of communication that is built on accurate relativistic time. This new research is the first major step toward making that future possible. But it also affects science. Understanding Martian time deepens our knowledge of relativity itself. It helps us refine Einstein's equations in real-world conditions, far beyond laboratories on Earth. It pushes our understanding of how clocks behave across the cosmos. And it prepares us for what's coming. Because one day, astronauts will walk on Mars permanently. One day, there will be habitats, bases, transport systems, and satellites surrounding the red planet. One day, Martian Standard Time will be more than an idea. It will be a necessity. And now, thanks to this breakthrough, we know exactly how time behaves on Mars. Faster, uneven, always shifting. So here's the question. When humanity finally builds a city on Mars, what time will it be? Earth time? Mars time? Or a brand new cosmic time zone? The future of interplanetary life depends on the answer.